Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so in this problem we have a parallel plate capacitor and we have a sine wave for the potential, and we want to know what is the maximum value of the magnetic field, and then for part B plot the magnetic field inside and outside. So the magnetic field inside will grow linearly and outside will vanish as 1 over r. So we can first write the expression for the potential. So V is V max sine of omega t. And we have the values for it. So V max is 150 volts and omega is 2 pi times 60 hertz. And now for the magnetic field, we use that the electric field inside is uniform, so E is V over D. Then we have that the magnetic field B is just mu 0 epsilon 0 R divided by 2 d dt, and this is mu 0 epsilon 0 R divided by 2 d dv dt. This is for inside, so R smaller than capital R. And because we want the maximum value of the magnetic field, we wanted the value where R equals to R. This is when all the induced current is being felt by the Gaussian surface, then is contributing for the magnetic field. So because the potential is sine wave, the derivative will be cosine. So we have that B is mu 0 epsilon 0 R divided by 2d V max, and the derivative is omega cosine of omega t. And the maximum value of this is when we have omega t equals 1 and r equals capital R. So we have B max is mu 0 epsilon 0 R V max omega divided by 2d. Plug in the values here, we obtain that the maximum value for the magnetic field is 1.9 times 10 to the minus 12 Tesla. This is for part A. Part B, you want to plot this function inside and outside. Inside, we already have the expression, is this one. So this is for R smaller than capital R. We can find the expression for outside doing the same thing. So we have for outside B is equal to the B max is equal to mu 0 epsilon 0 R square V max omega divided by 2 RD. So the only difference is this dependence here of 1 over R greater than R. And then if we try to plot this, so this is for outside, this is for inside, and then we have the plot is something like growing linearly until we reach the distance r. and then it goes like 1 over r. And this is the maximum value, Bmax. This is for B, this is for R. So the maximum value grows linearly and then drops as 1 over R.